special data structure to solve this problem. So the data structure that we are going to use is stack. Why? Why are we using a stack over here? Think of this. Now, this is the brute force code that we have. Now, understanding this is important. If you don't understand the brute force code, you will not be able to optimize the solution. Lines of code is so very less. It's just how many? Hardly 6 lines of code. But the logic here is being derived from what we have done in the brute force. So if I Hi everyone, welcome to my channel Code with Ease by Varsha. We are going to solve this LEETCODE problem today, the largest rectangle in histogram. These are the companies in which this question has been asked, and it is a LEETCODE hard problem. Now forget about the difficulty level for a while. Let's try to focus more about understanding the question and the real life applications if it has any. So first of all, what's a histogram? Histogram is something which we might have done in our high school mathematics, a graph that we plot to find out the frequency distributions. Now talking of real life application, see, the histogram that we have given, these represent certain data points. Now you can think of data points as something like maybe stock prices. You can think of it maybe temperatures for weather forecasting. You can think of it maybe some traffic data points. Now any kind of data point that is being plotted over here in order to do some trend analysis, probably the volatility of the stock market. So any kind of trend analysis that you want to do that, this question is helpful. Why? Because you are given an array of integers, heights, which represent the bar height, the histogram bar height, and the width is of 1. You have to find out the area of the largest rectangle. So like I said, if you're given certain stock prices, you can think of it. The area of the largest rectangle, so whichever represents the largest area, probably might be the area where the stock price has been the most volatile. Right? Or maybe if it is a case of temperatures, it can be the area can give you the trend that this has been the time of the year when the temperature has been at the peak or it has been at the lowest, whatever be the case. So this is how this question is relevant to us. Now let's dive into understanding how do we solve this question. Okay, now the question is, how are we actually trying to find out the area of the largest rectangle? As given in the picture over here, these are the different bars. It has been told that this particular portion, which is highlighted in red, the area is coming out to be 10. Why is it coming out to be 10? Because the height is 5 and the width of each bar is 1. So 1 plus 1, these two. So 5 into 2 is 10. So this is how the area is coming. So now let's first try to do a dry run and understand the brute force way of solving this question. And then we'll slowly move towards the optimal solution. So first let's try to figure out how is actually the area being calculated. Let's move to the whiteboard. Understand how the area is being calculated. The simplest formula that we have seen is height into width. This is how the area is being calculated. What is the height? What is the width? Let's start with the first bar, which is 2. So now what is the height of this? 2. What is the width of this? 1. Now, how do we know the area is 2? Because 2 cannot extend any further. The next bar is smaller in size. So you have to only calculate this much. That is, the area is 2. Moving to the next bar. This is 1. The height is 1. What is the width for this? 1. But we see that to calculate the maximum area, this bar can actually extend till the end of the array. Because everything else is greater than 1. So that is why the area for this, now the max area that we are trying to compute, now the max area that we want to compute now is becoming 1 into 5. 1, 2, 3, 4, 5. 1 into 5. So now the max area is coming out to be 5. So 2 will be cancelled. We have captured the max area is 5. Moving to the next bar. Now in this case, what is happening? Height is 5. But we see that the next bar is greater than 5 because 6 is greater. But 5, so 5 can extend till the right. So now the width is becoming 1 plus 1, 2. 5 into 2 is 10. So that is why this was the highlighted portion. So now the new area is coming out to be 10, which is greater than the previous max area. So 10 is the max area. So this is how it goes on. So what do we understand from this? Firstly, height into width is used to calculate the area. Any bar that we are at, we have to see from this diagram, if I say, we have to see if the next bar is actually greater than it. If it is greater, fine. But if it is smaller, we have to stop there and we have to calculate the area. So far we have understood. So what is a brute force way? If I have to implement this in the form of a code, how will I do this? The brute force way of solving this will be, now this is the brute force code that we have. Now understanding this is important. If you don't understand the brute force code, you will not be able to optimize the solution. So what is this? We have outer for loop, we have inner for loop. We are calculating, we are initializing min height at the start of every loop to be max value. So we are considering every bar, okay, starting with the first bar, and then we are traversing rest of the array. Then we are again considering the next bar, and we are considering rest of that. So what is the main thing we are doing? We are calculating the min height over here. This is the crux of this is the main basis of this problem. We are calculating the minimum height. I'll tell you the reason also. I've written over here. If I consider this particular portion, 156, it is like 1 versus 5, 1 versus 6, which is the minimum out of this. 5, 6, 2, 3. Among all this, 1 is the minimum. So what we are getting? We are getting minimum height into width, and we are calculating the area. And that is how we are being able to calculate the area. If I don't get the minimum height, I will not be able to calculate it, because the minimum height is something which is going to go till the end of the array. You can think of it like this. If it was the opposite case, like we have in this case, if we consider 6 and 2, 6 cannot extend any further. So 6's area, the area is confined to this particular bar itself. So that is why at the start of every inner for loop, we are calculating what is the minimum height. Given wherever your j pointer is, if that particular height is the minimum, or whatever you have already stored in your min height. So basically in this, we are calculating the max area with respect to finding the min height. So if you are able to find out the min height, with we can easily calculate j minus I plus 1. So I will just do a very small dry run for just these two bars, 5 and 6. So what is happening over here? Your outer for loop is over here. And now j is equal to I. Initially your j will be equal to I. What is your min height going to be? 5 itself. And then 5 into whatever your width is going to be, it is going to be 1 itself. That is 5. When the j moves over here, now your width is 2. What is your min height now? So previously your min height was 5. Now heights of j is 6. So 6 and 5, which is the minimum? 5. Now we can understand this 5 has extended over here. When your j is here, it's like 5 has extended over here. So now we see minimum height is 5 and your width is equal to 1 and 2. So 5 into 2, 10. So this is how your max area of 10 was being computed if we just consider this portion, 5 and 6. So again, why this is important is if you understand this concept of finding the min height and how this min height is actually meaning that you are able to extend it to the right and actually able to calculate the area by multiplying with the width, because this is going to be the basis of how we try to optimize the solution. Why do we need to optimize the solution? Because this solution involves two loops and we know that both of them are traversing. So first outer for loop is going till n, the inner for loop is also going till n. So it is n square complexity, which is not optimal in any case. So we have to optimize this. We have to do it in O of n. That is our requirement. So now that we have discussed about the brute force and kind of understood with dry run, so now let's try to think about how do we optimize the solution. In order to optimize, we have to understand some pattern. We have observed a pattern. What is the pattern that we have observed? The pattern is increasing order of heights. What do I mean by that? If you again see this 1, 5, 6, I'll again repeat this 1, 5, 6. This is the increasing order of bar 1, then 5, then 6. When this is the pattern, the area is getting calculated very easily. I know that 1 can extend to 5 also, it can extend to 6 also. But the moment it falls down, I mean, now forget about 1, 5, 6. Now just think about 6 and 2, these two bars. So 6 and 2, it's suddenly dropping. The height is suddenly dropping. Now when it is suddenly dropping, in this case, what is happening is your area, so your bar of 6 cannot extend to the right. So your area is now confined to this only. So why do we need to understand this increasing order of the bar? Because this is what will help us in determining what data structure can we use to solve this problem. It is not going to be simple for loop. We have already seen just by using for loops we cannot. We have to use a special data structure to solve this problem. So the data structure that we are going to use is stack. Why? Why are we using a stack over here? Think of this. When I used two for loops, I had the luxury of traversing the array twice, like one loop within one loop. When I'm trying to optimize, what I can do is as a starting point, I'll add int I equal to 0, continue till n. I do not have the luxury of using another for loop to do the rest of the traversal. So think of it like this. Like I said, increasing order of height. So I have 1, I have 5, I have 6. After 6, it has fallen to 2. So this is the increasing order. I'm great. I'm fine with it. Why? Because when I'm in this particular sequence, 1 into 3, I got the area of 1 into 3 is 3. Forget about 2 and 3 for now. When I'm at 5, I got area of 5 into 2, 10. When I'm at 6, I got the area of 6 into 1, 6. The moment it fell down to 2 is where we now know that this pattern is being violated. So think of it like this, how we are actually trying to use the stack and why we are trying to use the stack, most importantly. So let's say I have piled up one after another. I've pushed into stack 1, pushed into stack 5, pushed into stack 6. Now we are trying to understand how by using the stack we are able to do this. We are able to achieve this functionality without using another for loop in between. So we are simply traversing. We are adding to the stack whenever there is an increasing order of pattern. Now, the moment you encounter 2, what we will do? I will not push into stack because it is violating the pattern. What I'm comparing, whether my current value is it lesser than the top of the stack. If it is lesser, I need to pop it out because my pattern is being violated. I'm going to pop it out and I'm going to calculate the area then and there. For 6, what is the width? 6 into 1, so I got the area of 6. I'll remove 6. Again, 6 is removed. Is 2 lesser than 5? The top of the stack is 5. Yes, it is. Now, what is the width so far? Width is 2. Like we said, the width is 2. So now what is my area coming out to be? 10. So my final max area has now come out to be 10. I'm going to remove 5 again. Now I compare 2 with the top of the stack 1. Is 2 less than 1? It is not. Since it is not, now I pile up 2 on top of the stack. Now you see, again my sequence, my pattern is being established. I have 1 and I have 2. It is in the increasing order. And then I carry on with rest of the values. So this is how basically by using single for loop and by using the stack, I am being able to pop out the values one after another, calculate the area then and there using the same formula of height into width, and we are being able to get the max area. So it is like doing a backward traversal. It's like doing a backward traversal. Why we are doing a backward traversal? Because we do not have the luxury of staying at a bar and then looking forward by doing another traversal for rest of the array to find out the min height. We do not have that luxury. So what we are doing is we are making use of this concept of increasing order of height, the pattern that we saw. If it is an increasing order, like we have seen over here, then we keep on piling it on top of the stack. The moment something is violating this particular pattern, we start popping out from the stack and calculate the area then and there. Let's do a dry run. So I've just taken the main code snippet, which is anyway going to be available on the GitHub. So we have a first for loop, okay, that we have. Like I said, only one for loop we have. We have a while loop. Why is it while loop? It is going to iterate through it, like the backward traversal, like we said. So forget about stack empty I equal to n, forget about all of this code. Focus on this particular code. Heights of I, my current height, is it lesser than what I have at the top of the stack? Is 2 lesser than 6? We were doing this comparison, right? Is it lesser? If it is lesser, this while loop will start. What we are doing, we are popping out the number. So it's 2 less than 6. We popped out 6 and we stored it into this height variable. So my height is 6. My width, how am I calculating the width? Of course, if the stack is empty, it is going to be the number itself, the ith value itself. And if it is not, it is the same thing, I minus stack dot peak minus 1. Now remember, what are we adding to the stack is the indices. I just added the value to make it more understandable, but actually we are storing the indices in the stack. So that is why we are, every time we are taking out the value from the stack, we are actually putting it in the array position. Whenever we are taking out the value from the stack, we are adding it as an array's index. So now the point is the width. How am I calculating the width? Over there I was calculating j minus I plus 1. Here how am I calculating the width? I is the current position. Stack.peak is going to store the position of the particular bar which I am supposed to remove. And that minus 1. So in this case, I is equal to 4. Now because I have popped out my peak when I removed 6 already, the first thing we are doing is we are popping it out. So we are doing stack.peak. Now peak was containing 5, which means it was containing index of 2. So peak is giving me index of 2. And 4 minus 2 minus 1 is going to give me 1. 2 minus 1 is going to give me 1. So the width I got is 1. So what is this? This is establishing a boundary between this and this. Boundary between the index number 4 and the index number 2. I am only interested in this particular. Okay. Now you might ask, what is happening when I am removing 5? Then my I is 4. My stack.peak, because I removed 5, now my peak becomes 1. So 4 minus 1 minus 1, which is becoming 2. That is why in this case, the boundary which is coming is this. This to this. This is the boundary, which is of width 2. So that is why in this case, you are getting 5 into 2 is 10. So this is how we are calculating the width. Now we got the width, we got the height, and we are multiplying it to get the max area. This remains the same. This logic remains the same. And once this while loop is exhausted, so ultimately we are going to return the max area itself. So we are computing and storing it in this variable from time to time. Now when will this while loop be over? Now when will this while loop be over? This while loop will be over when this condition will no longer be true, right? Or if, of course, if the stack is empty. What I said, 2 and 1 when we were comparing, 2 is no longer lesser than 1. So then this while loop is over. Once that is over, I'm going to push on to my stack, my current value, the ith value. So that is why I push 2. And this is how when I'm pushing on to this, I'm establishing the increasing order of indices again. So the number of lines of code is so very less. It's just how many? Hardly 6 lines of code. But the logic here is being derived from what we have done in the brute force. Okay, one more thing I missed out is if the stack is not empty, why are we doing this check? Because if the stack is empty, obviously I cannot pop. That is something which I have to check. Now another question is why are we doing this? I is equal to n. This is for establishing that boundary when I want to understand the area for the last element. So my I will reach over here, which is n, which is of course there's no element over here. Then I will do the popping from the stack and calculating the area. So this is for establishing that boundary because you see wherever your I is, if your I is over here, the boundary begins just before that. So from there till wherever your width is coming out to be. So for establishing that boundary, we need this I equal to n. For not popping, for the underflow to not happen, we are checking if the stack is empty or not. And this is the main condition that we are doing. And ultimately, we have to push to the stack for establishing the increasing order of indices. So this is how in just hardly 6 lines of code, we are able to solve this particular question. Largest rectangle in a histogram. The code will be available in the GitHub. If you are not able to understand this, I would suggest to again rewatch the video, try to pause, do a dry run, again watch the video. This is how you're going to understand. And finally, write the code on your own. Unless you write the code on your own, or unless you do a dry run first, you will not be able to absorb this concept. And doing that is important. So, thank you so much for watching this video. Thank you for sticking to the end. And please don't forget to like and share and subscribe to the channel if you haven't already. It just gives us more motivation to put in more effort like we have done here to bring out more valuable content like this. Thank you so much for watching.